this is like a rocket.
Yeah.
So a module like this, you know, how much power or what does it contain, if I can ask that way?
Yeah.
I mean, we saw this one here is 3,000 Farad. Yeah.
Yeah.
So this, how much would that be?
To explain that, I would like to show you also the
Take that
the
back.
different technologies that are the most used technologies that are in the market.
Yep.
Because a supercap is often used for power applications.
Okay.
If you look at a capacitor, then the ultracapacitor can store energy, but it's less than compared to batteries or fuel cells. Still, it has much more capacity than conventional capacitors. So it's somewhere in between, and usually what we see is that a supercapacitor can be very interesting technology for capturing regenerative energy or for applications where you need very high power during a short time. Because the big advantage of ultracaps is that you can charge them and discharge them with the same power, and they have a very low internal resistance, and therefore they can deliver a lot of power.
So very quickly.
Very quick. They can release it instantaneously, much quicker than even than a battery.
Aha. Okay. So what kind of applications need that kind of energy, basically?
Yeah, you can imagine, for instance, for stabilizing a DC grid.
Yes. Okay.
Where you have a high cyclic load.
Yes.
And you have energy sources that cannot follow this dynamic load.
Yes. Yes.
Their supercaps can be very good technology to use.
Okay, to understand. Okay. And just going back to this diagram here we have energy density versus power density. Okay, so this means how much energy am I storing per kilo, so per weight. So so there you have, okay, batteries higher, and I mean fuel cells, okay, when they convert from hydrogen also higher. But the supercapacitor in terms of energy density is lower, but seems to be much higher, and this is a logarithmic scale here, in terms of power density. So,
yes.
so I do not have to carry much weight to have a lot of power, but it's for a short time.
Exactly, yeah.
Okay.
So it really depends on the application, what the best technology source is.
Okay. Now, this is wild, but this is like a rocket.
Yeah.
Anybody ever thought about building a rocket with this? I mean, if you need a lot of power for a short time, I mean, ever thought about that at AP hybrid power?
We are not into a rocket or space applications yet.
Okay.
But I know that they are also used for aviation and also for space technology because of the big benefits that they have. They can work with a very big temperature window from -40 to +60 degrees. They also have millions of cycles, and they can last for maybe 10 to 20 years in an application.
So okay.